Hooman, he has over 12 years of experience in transportation and infrastructure asset management and developing decision support systems. He received his bachelor's degree in computer science and his master's degree in industrial systems engineering. Hooman is the CEO and president of Bridge Intelligence. You've seen him as one of our vendors out in the hall, exhibit hall. InspectX, ManageX, EmergencyX. What I'm going to say is I'm really pleased to have him up here.
Hi, everyone. Thanks for being here. I'm going to talk about tablet-based bridge inspection platform and how it can help DOTs and consultants do the inspection basically more efficiently and in less time. The problem that we see is that more than half of state DOTs right now still use pen and paper and camera to collect data. Why is that a problem? Basically, inspectors have to carry a lot of things with them, like a paper form from last inspection, an empty paper form, a camera, maybe manuals. So a lot of things to carry. Then there's no data validation when you're using pen and paper. A paper cannot tell you that this is not the right data that you're entering. Most importantly is that when inspectors go back to the office, they have to enter the same data that they collected into their software. They have to download those photos from their cameras, rename them, and then upload it to the software. There we see a lot of time that is being wasted right now that potentially could be saved. And the numbers that we have is between 1 to 3 hours, depending on the DOT and the practice. But there are some DOTs, and this is for a routine two-span bridge. And sometimes numbers go even higher than that. For example, we work with Tennessee. Their number is a little higher, like 4 hours. And also, the quality of the data will be lower when you're using pen and paper because of no data validation. So solution is that it's year 2021. We get into 2022. Everyone has like a smartphone or a tablet that can be used. And we should utilize these devices for field data collection instead of using pen and paper. Solution can be a mobile-based bridge inspection that is basically it's agnostic in terms of like if it's Android or iOS. It can do offline data collection. You don't need to have cell reception in the field. You can do text-to-speech to make things faster, more efficient. You can do all sort of data collection for element, all agency fields, everything, and do sketching, images, and text. I'm going to walk you through a regular workflow for inspection and how this tablet-based inspection is going to fit into it. But first, I'm going to, like an inspector or inspection manager wants to go about doing the planning for the inspection, they need to check for upcoming inspections and overdue ones. And then they need to schedule these inspections for these bridges. Go over them and just look at these two. And right now, DOTs, a lot of them, what they're doing, they are having Excel files outside of their software that they're basically creating queries to see like what is upcoming, what are the set of bridges for routine inspection next month or the month after that or underwater. And that's another part that we see it could be more efficient so they don't need to do this in another application that should be integrated with their inspection management application. And basically that can be easily done with a query module that you can query your upcoming and routine inspection. You can filter down and then see where these inspections are located so you can better plan for how you want to bundle them up together and schedule them. So once you're done with that, then we need to, when you're using a tablet-based inspection, you want to do offline inspection. In order to do offline inspection before going to the field, you need to download that data to your tablet. Once you download it, you can go to the field and do an offline inspection. We're going to go through that as well. Once you're done with the offline inspection, you come back to wherever you have internet, you upload the data back to the server, and the point is that then when you come back to the office, no more manual data entry, and that can save you at least an hour of work for every bridge, even for smaller bridges. And you submit the inspection for approval, and then reviewer or reviewers go and review them and approve them. Let's focus on the tablet data collection a little bit. There are a lot of things that I'm going to cover. I have screenshot for them, so we're going to see how we download the signed inspection to your working set. You can do an offline inspection, then you can use the tablet or mobile to get direction to your bridge. If it's a larger state like Arizona, you might not know how to get to the location of the bridge. The tablet can help you with that. Use the different forms as part of the application to go and do your data collection in terms of elements and defects and maintenance and deficiencies. You can collect channel profile or do sketches and the photos and photo logs and then sync the data back to the server. So I've included some screenshot to just give you an idea how a platform could look like. Basically, this is where your working set lives, and this is where all your offline inspections that are available for offline live. These are some of the forms that you can expect in the field that your tablet-based application provides to you. So it can be exactly the same as your paper forms. It would be customized based on DOT's forms, so it'll resemble those. One of the things that can be useful as part of when you have a tablet-based data collection is that when you're adding stuff or you're modifying stuff or removing stuff, let's say removing a defect or a maintenance item, if it's fixed or completed, you can, since you're using a software, you can use color coding to make it visually more understandable what has changed as part of the inspection. So that's something that we do whenever you have an element or defect or deficiency. When they change, we make them orange. When they're new, we color code them as green. And when they're removed, we show them so reviewers know that that element or that maintenance item has been removed, but they cannot modify it anymore. So it shows it red. So this is a sample screenshot of like an inspection form. You see those yellow ones are the ones that like Deck Super Sub has been changed. This is a view of like your maintenance deficiencies. You can see easily that like the green one was added as part of that inspection. The yellow one was modified during that inspection, and the red one was removed. Same thing for elements and defects. So you can color code them, and then when you add in data, all the quantities will automatically be updated. This is how you add a defect. So for example, when you're adding the defect, a software system can basically avoid going beyond the element quantity. So those type of validations, they're all built into the system. An application can allow you to do sketching. Some of them do, some of them don't. So with sketching, you can either mark up the photos or just do hand sketch or put the shapes. Or you could have your templates for DOTs that they have like different templates for abutments or like wing walls, and they draw on those and basically mark up all the conditions. Your channel profile can be basically done through the application based on the way state do it. So, and you can see graphs that show you how the channel profile is and how it changed throughout the time. Then any application that is going to be useful should provide you with a good photo taking capability and photo log section that you can basically view the photos that you've taken. You can associate them with different components or elements or defects. Once you're done with the data collection, wherever you have internet, you sync the data, and then there's not going to be any more data entry back in the office. You can just check it, but all the data that you've done, collected as part of the field data collection, is going to be there when you go back to the office. So one thing that we see is that sometimes there might be conflict if there are multiple inspectors that are doing inspection. So there can be conflict resolution if like inspector A changed like a field from 5 to 4 and then another one changed it from 5 to 3, then reviewers can go look at it and see which one is the correct one. And also the reviewer can see a log of everything that changed as part of that inspection to make it easier to review the whole inspection, just seeing the change rather than going through everything one by one. Then you can create inspection reports, PDF inspection reports based on DOTs have different look and feel on their report. wanted to do a case study for Utah and North Dakota, a couple of states that are part of this partnership. There are our clients, and they do inspection both in-house and also they hire a lot of consultants to do those inspections. Some of those consultants, we've listed them there. As far as we know, more than 95% of both in-house and consultant use tablet when they want to do the field data collection. They use the app. Consultants have the different access level based on their, if they, for example, been with concert, they have like access to District 1, for example. They shouldn't have access to District 2 bridges. So the DOT decides what access level each consultant should have, and depending on the consultant, if it's local or state, there can be different review process, multiple level. I checked a couple days ago, there were about 8,000 offline inspection that was done in the past 2 years for North Dakota and Utah by all these consultants and in-house staff. Once they do that, both North Dakota and Utah, they have BRM and they have our software as well. These two are integrated with each other. So BRM is a very good software for management, for inspection. There is room for improvement. So what our software does, it basically complements BRM and it's integrated with it. So once you go and do your inspection, approve it, automatically the data goes to your BRM, so you can do all the management stuff in BRM. Just wanted to have a slide about the new coding guides. I know everyone asked for when is it coming, and I don't think anyone has the answer, but one of the things that we did in our software is to implement the new coding guide into our software, so whenever it comes out, basically our DOTs, they're ready to use it. So our software supports both the current NBI coding guide and the new coding guide. So you can do data collection in both systems at the same time. So if when it comes out, a district can just pick up the new coding guide data collection, and then they go and do the data collection for some times and come up with some best practices for other districts in the state. This way, the transition, we think that the transition from the old coding guide to the new coding guide can be much easier. So that's something that softwares can help DOTs to transition to the new coding guide easier. That's my presentation. Question is that if there is a desktop application or is it only apps? So there are different components. One is the web module. So when you're in the office, you access it through your browser. And when you're in the field, you use the tablet to do offline data collection.
Hooman, thank you.
Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.